Oh dear, I seem to be sleeping on the job. But when you're traveling 1,000,000 miles a day, that's on schedule for good old Dr. Cortex, now is it? But it's great to see you once again, and you seem to have woken me up just in time too. We have another question of the day to answer, so let's go ahead and get that answered. Now, this one is from Nicole, and she asks, Dear Dr. Cortex, what is the most common type of star in the galaxy? Well, quite frankly, Nicole, that is a very straightforward question. The most common type of star in the Milky Way is called the red dwarf. You see, there are several types of stars, and this particular type, the red dwarf, is slightly smaller, slightly cooler, and slightly dimmer than most other stars. But they account for over 75% of the stars in our Milky Way galaxy. Anyhow, good question. Good question for everyone to know, as a matter of fact. But, as I always say, let's not dilly-dally. We are going to be it's already been discovered, exploring quite a strange planet today. That planet being Uranus. Fire the engines, computer. We're going to Uranus. Here we go. I went ahead and I grabbed some data beforehand. Now, the planet Uranus, named after the Roman god of the sky, was discovered in 1781 by an astronomer named William Herschel. Now, the reason I say that, everything that we have discussed so far, the Earth, all of the planets that we've talked about so far, and the Moon, they have all been known to exist by humanity since antiquity. But luckily, in 1781, another planet was added to the solar system roster by this young man right here. Now, Uranus is a very, very strange planet when it comes to rotation. For you see, how do I put this? Remember how, as I have said before, all of the other planets have an axis, and they rotate on it like a top. Yeah, have you ever played with a top? You know, you spin the top, and it goes around and around. Well, that's how planets work as far as rotation. But Uranus, being the oddball planet, actually spins on its side because the axis is tilted over by over 100 degrees. That's like taking its axis, see, I've got it right here, and doing this to it. So it's on its side. Now, that really does have some of its strange side effects. For you see, when Uranus goes around the sun, it does have day and night, but one hemisphere actually experiences 21 years of complete daylight, and the other 21 years of complete nighttime. Anyhow, the rotation of Uranus, as it spins on its side, it's about 17¼ hours for each little rotation there. But considering that this is about 1.8 billion miles away from the Sun, huge jump from Saturn to Uranus, it's about 84 years for Uranus to go around once. Go around the Sun once. Truly incredible, and that number will continue to grow as we go outside for further outward into the solar system. Now, as for the size of Uranus, it's about, the diameter is about 31,763 miles, which is about, I'd say, 4 or 5 times the size of Earth. Now, being it that it's larger than Earth, it would logically have a larger amount of gravity, a force of gravity bringing down satellites. And it has a considerable amount of moons, being it 27. Of course, not as big as Jupiter, Saturn, because, well, they're the 2 largest planets. Ideally, but still, I'd say 27 is a rather good amount, won't you say? Now, planet makeup. We say that Uranus is a gas giant, but some scientists really like to call Uranus a ice giant, because it's sort of this weird mixture of liquid and gases. For you see, really, the atmosphere of Uranus, it's about 83% hydrogen, 13% helium, about 2% methane, and of course you have your trace gases somewhere in there too. But really, the identity of Uranus comes in its makeup. You can see the outer layer, the quote-unquote atmosphere. It's mainly composed of hydrogen and helium all around there. But as you go further inward, you start to see some of these liquid substances like ammonia, methane, and some water, quite frankly. There's some trace amounts of oxygen in Uranus that allow for water to exist. And at the very center of Uranus, scientists, they hypothesize that there is this dense ball of ice. This dense ball of ice at the very, very center of the planet Uranus. But as far as weather goes, Uranus, again, is not a very pleasant place to visit. The average temperature there being negative 355 degrees Fahrenheit. Now, obviously, that goes without saying, sort of contributes to the distance from Uranus to the Sun. That 1.8 billion miles really is connected to that. And being that it is a gas giant, Uranus has wind speeds of about 560 miles per hour. And it also, well, along with its moons really, it also has some very thin rings around it, but you can't really see them that well. But they're there. They are there. If you get a really powerful telescope, you will be able to see them. Well, I must say that Uranus is probably one of the most oddest planets that I've really looked at, but it is a planet that we can call our own. But one thing that really isn't odd around this time, getting rather hungry. Well, you know who to call, my friends. I am Bot! What have you got for us this time?
Well, you see, Doctor, today, using the schematics I collected from Uranus, I created a recipe called Frigid Cores of Uranus. Now, you need to grab a fruit juice of your choice, toothpicks or popsicle sticks, and an ice cube tray. First, pour fruit juice into each ice cube tray slot. Then, stick a toothpick or popsicle stick into each slot of the ice cube tray. Finally, place the ice cube tray in the freezer and wait overnight for your frigid cores to freeze. That's all there is to it. Back to you, Dr. Cortex.
Why, thank you again, my metal friend. What a cool treat to snack on. Well, I'm afraid that it is almost time to go once again. But before we go, let's check out the computer and see what we're going to talk about next time. Computer, do your stuff! it appears, my fellow space cadets, that we are going to talk about the planet Neptune on our next segment. Just want to give a big shout out to Nicole for providing us with the question of the day. Another great question, in fact. And again, if you all have any questions or comments, of course, you can always leave them below in the comments section. Who knows? Your question might be featured in the next entry. But with that being said, I think it's time for another blast off. Ta-ta for now. In 3, 2, 1.